only do I make you guys a review that you trust me now, that is like your test, right? You know it is. You should be able to trust me. But I was literally sweating last period, getting these problems done, making sure I fit it within the class periods for them. I would get an A on this test, okay? So please take advantage of the fact that I make these nice reviews for you. I work out the hardest problems with you. I make a video of it. I really need you guys to take advantage of it. This is your last test, last big grade of the quarter, okay? So at least fake that you're paying attention to what I'm doing, okay? Act like it. What I'm going to do is 7 through 12, the calculator multiple choice, and both FRQs. Definitely the FRQs, I'm going to give you a lot of, I'm going to be writing out all the work and everything, because I'm going to be a little more strict with how I grade the FRQs going forward, and I'll explain what I mean when I get there. But let's go through the calculator problems, which actually aren't that bad, together first. Please let me know if I'm going too fast or if you don't understand something, and I will happily explain it. Okay? All right. So starting with number 7, suppose you invest $3,000 in an account that pays an annual interest of blah, blah, blah %, compounding continuously. Oh, that's the PERT formula. Here, they already gave us the PERT formula with the 3,000 plugged in, the percent changed to a decimal plugged in. Yay, okay? So all of that's done for me. So invest, that's your principal, the P part of PERT. And the question is saying, use this equation to determine how many years, so T is time, how many years, right? How many years it will take to double the...
Good morning, countryside. Here are your daily announcements of Cougar Country. Boys and girls basketball are in full swing, and over Thanksgiving break, the boys had 2 great wins over Patel and Alonzo High Schools. Their next game is at Tarpon Springs tomorrow. Good luck. Tuesday, girls and boys soccer versus Clearwater at 6 and 8 p.m., and girls basketball versus St. Pete at 7 p.m. 3:30, track has a district meeting. 6:15, boys basketball at Tarpon Springs. 6:30, JV wrestling is at Largo. 6:30 p.m. JV wrestling at Eastlake. 7:30 a.m. chorus at St. Trevor's Spa. 3 p.m. wrestling at Osceola High. 5 p.m. chorus at Bayside Church. 5 and 7 p.m. girls and boys soccer at Holland. 6:15 p.m. boys basketball versus Chicago here at Tennessee. Your freshman sophomore classes are holding a candy gram fundraiser starting September 2nd, 19. Visit Haley's announcements for all these things. Tabletop and meet after school on Monday. STA meetings during both lunches. Wednesday after school. Our club is in N14 and Q Club is in L8. Thursday is first priority club meeting during both lunches, and after school French National Honor Society is K8. Chess club is in A6 and academic team is in N2 and N5. Friday there was Cyber Patriot meeting in K5. Wednesday, Coffee Cart will be selling iced coffee for $3 every Wednesday morning. It will be in front of the main office in the concourse. You can pay in cash or purchase Punch Card with 7 coffees for $20 on rev check. Reminder to students that we enter testing season. Charge and bring your laptop and charging cords every day to school. Testing will be Wednesday, December 3rd through Friday, December 5th, and Wednesday, December 10th through Friday, December 12th, starting first period. SLCE Civics exams will be Monday, December 8th.
Sydney, are you good?
December 9th,
are you in the program? Okay.
Fast retakes both on December 15th, starting second period. Have a great day, and thank you very much.
Okay, so your principal P is $3,000, and what it's asking is how much will it take for the account, your investment to double? That's how much you would make after your investment time percentage rate. So what would A of T be? 6,000, right? If you invested 3,000, how long will it take for you to have 6,000? Maybe you have a goal for that. You're buying something. So I need to know how long it's going to take me under these conditions to make $6,000. Okay, so guys, this is T and A of T. That's your X and Y, right? And this is that classic thing we keep seeing in this class. Given Y and you need X, you use intersection, okay? So you treat each side of the equation as a Y1 and a Y2. So Y1 will be exactly what they gave us. And I know this is really small in these reviews, so it's hard to see where the decimal is. But be really careful typing it in. On the test, I kept it regular size, of course. And then y2 is the other side of the equation. So I'm going to make sure you clear your RAM. And guys, you want to do this when I'm doing this, because when it comes time for test day and you're like, where's the E button? I'm not telling you, because you should have been doing that in class, so you would know where the E button is, okay? So if you don't want to do this with me, that's fine, but just know I'm not going to help you on the test day with your calculator. Like if it's frozen or something like that, of course I would help you. Okay, so the E button is above your natural log. So second natural log, and it gives you the E and moves your cursor up, and then you would type in whatever it says, 0.0525, and of course we'll just use X. And then I'm going to put in 6,000. Now listen, I'm not even going to bother hitting graph yet. I know that my calculator window only goes out 10 units in all 4 directions, and I just told my calculator to go up to Y, that's a horizontal line at 6,000, okay? Also, all of my X values, my T values, my options, are greater than 10. So you need to go to Window and change that. So let's start with X max. You want to include all of these. The biggest number there is 15. Maybe we put 20 for our X max. Is there a wrong answer there? Not really. As long as when we get to the graph, you can see the intersection, we don't all have to have the same X max. These need to be included, and I always go a little further, or maybe a lot further. Just make a decision. X max, we know it has to go up to 6,000, and I want to go more than that. So 7,000, 6,500, you make your own decision. And then hit graph. You know you made good decisions on your window if you can literally see where they intersect, okay? You need to give your calculator cursor room to move around it. So if it was like way up in the corner, you would just go back to your window and adjust it. Further to the right, further up, both. You just need to be able to see the intersection. And then we go to calc, which is above trace. It's blue. So second, calc, intersect. And intersect's the easiest one. You just hit enter 3 times. Enter, enter, enter. And it says it at the bottom. When y is 6,000, x is 13.2. So listen, this is where you have to make a decision, because you're narrowed it down, right, to 13 or 14. This is one of those situations you would not use typical rounding rules, because obviously 0.2 would make you go to a 13. This is a real life problem. We're talking about money. After 13 years, have we made 6,000? No. We're now into the 14th year, 13 plus a little bit more, so you would choose 14 in this situation. Okay? Number 8 is the only problem on the whole test that you have to show work. Okay? So it's the only one, and I will be looking at your work. So let's talk about this. Given f of x, use limit notation to describe the end behavior of the inverse. So, and it says show correct work for credit. So we have a log. Let's get this in our head. The inverse of a log is an exponential. Inverse of an exponential is a log. So we know we're going to go from log form to exponential form. So I'm going to go over here and rewrite this equation, switching x and y. Okay? So we know this is y, and we're going to switch x and y. So x equals, so make sure you show the work. I will be looking at it. So in a minute, we're going to rewrite this log in exponential form. But you have to remember sometimes there's cleanup to do, meaning when can we do that loop-de-loop thing? Remember base 2, power the other side, where I do the arrows? That's what we're going to do. But we have to have the problem look a certain way before you do that. And that is, you can only have the log, its base, and its argument on one side. Okay? So who is out of place here is this 2. If there could be another number over here that would cause a problem, like if there was a 1 over here. Okay? That's not part of the argument. It's not in the parentheses. So you would have to subtract 1, divide by 2. Okay? But in this example, the only cleanup there is to divide both sides by 2. Like, I don't need to see that step. I'm dividing both sides by 2. So I would get x over 2 equals log base 2 of y minus 3. Now we're ready to loop the loop. Base 2, power on the other side, equals that, right? Log base 2 to the power, sorry, I totally messed that up. I got distracted. Sorry. This is where I should be telling you guys to use pencil, but I hate using pencil too, so whiteout's my friend. Sorry about that. Start with the base 2 to the power of x over 2. 2 to the power of x over 2 equals y minus 3. Y is still not by itself. You would have to add 3 to both sides. So you would get y equals 2 to the x over 2 plus 3. Okay? That's the inverse. So I would need to see that's enough work. Okay? Now, how do we know what the end behavior is of this guy? Well, you have a graphing calculator. You could put this in Y1 and look at the graph, look at the table of values, but I'm going to kind of make it a little bit quicker. And I think this is helpful to remind you guys of what an exponential is. Exponential functions are j's or backward j's. This one's a j because it's the b value is greater than 1. It's increasing. You submitted? Okay. Thank you, sweetie. I told him, so just go ahead and go. And then it's moved up 3. That's that k value. A number at the very end, not in parentheses, that moves your graph up and down. So you might have seen on my key that I sketched it, but you could have used your graphing calculator. There's an asymptote at 3, and because it's an increasing function, b is greater than 1, it looks something like that. That's all I needed, and you didn't have to draw it as part of the work. That's all I need to be able to do my end behavior. As my x's get smaller, I approach 3. As my x's get bigger, I go towards positive infinity. Just be careful. Look at them really closely. And again, I know these are small print. They'll be regular print. Because remember, sometimes I do negative infinity. I usually do left and then right. These are all written as right and then left. Remember, there's no order. So just always be careful that you don't get confused between like the different notations, okay? So as x gets smaller, oh, that's not right, is it? Oh, no, that's x gets bigger. Yep, can't see. As x goes to the right, y's go up. As x's go to the left, y's approach that asymptote of 3. So that's right. Okay? All right, in this one, they give us an equation. B is level of sound. I is whatever it is. They give us an equation. They give us one of the 2 variables. Solve for the other one is basically all it's saying. So I have 10 log, in parentheses, I was given to us as 10 to the negative 5 over 10 to the negative 16. And now I have to simplify it. In that parentheses, guys, that's, I can use like bases, subtract my exponents. So that would be 10 log of, keep my base, subtract my exponents. Negative 5 minus negative 16, you can use your calculator, would give you 11. Now, I'm going to kind of combine 2 steps in one. Log base, there's a 10 here, right? Understood? Log base 10 of 10 is 1. So those cancel. And since this is a log, I can bring this 11 to the front, my power property. Well, there's already a number out in front. What do you think you do with the 11 and the 10? Yeah, you multiply them. Okay, so log base 10 of 10 canceled, and because it's a log, you can use your power property. Remember, exponent can come out in front and be a coefficient. There's already a coefficient there. I just multiplied them together. Got the 110. Good? I used to hate this problem, number 10. I felt like it was hard to explain. I don't know, something clicked with me, and I feel like it's a lot easier than it used to be. So I'm going to help you understand number 10. So we have the graph of f of x here. Which one of these is the inverse of that graph? Okay? So, guys, this is clearly not an exponential function. It must be a log, because these are exponentials. So this is a log, these are exponentials. Plus, logs have vertical asymptotes. I'm going to help you with one little piece of knowledge eliminate two answers, okay? One thing we should remember about inverses, and it's going to come up in the next few problems. Inverses is you switch x and y in any form. Domain and range are x's and y's. You would flip them in inverses. Ordered pairs, right, table values, you would flip them. Asymptotes are another one. This graph right here has a vertical asymptote at x equals 3, right? That means the inverse will have a HA at switch x and y equals 3. Well, that's one of these two. That's what takes your graph up or down. Because remember, an exponential function is going to look like a J or a backwards J. It has a HA that moves it up or down. That's that number at the back. Okay? That can help you narrow it down. But even if you didn't remember that or you didn't understand that, you could just go right to this method, which is what I'm going to do next, just with these two. If 4, 2 is a point on this function, then flip it would be a point on the inverse, right? Switch x and y. So you can plug and chug. You could plug and chug with all 4, but I just narrowed it down to 2 of them, all right? And without having to do it again, it ends up being this one. So I plug in 2 for x, 4 for y. Remember, anything to the 0 power is 1. 2 minus 2 is 0. E to the 0 is 1. 1 plus 3 is 4. Left side equals right side. That's only going to work with one of those equations. Okay? Good? Okay. You guys look so thrilled about this stuff. Remember, it's your last test. All right. Demand equation. I don't know what a demand equation is. I looked it up. It's just something they use in manufacturing. So it's an equation for a new stand-up desk is given here. That we understand. We understand equations. Find x when y is 300, when p is 300, which is your y. So when we have y and need x, that's intersection. Keep doing it. Here's another question, just like number 7 that we started with. So clear your RAM because you did thousands. And type them both in. It doesn't matter which one you put first. I'm going to change it up and put the 300 first. It doesn't matter. No sense in hitting graph yet, right? We already know we have to go up to 300 on our y's. And look at all your x values. Certainly bigger than 10. So x max, I need to include at least up to 857. I'm going to try 900. Is that big enough? I don't know. We'll find out in a second. And then y max, at least 300, 400, 350. You make a decision. And let's see. Okay. My numbers were good, as long as you can see the intersection. That's all that matters. Second, calc, 5, enter, enter, enter. There she is. And y is 300, x is 740. There would be clearly the closest. Good. And last one of these. Again, inverse. Understand what inverse is. The graph of f of x is here. Let g be the inverse. What's the max of the inverse? Okay? So remember what max means. Max is the y value of the highest point. So if the max of this graph is the largest y value, the max of the inverse, switch x and y, is the largest x value. Okay? So this little statement I wrote on here hopefully makes sense. And you're just switching x and y anytime, any form of x and y when we do inverse. So now I just look at this graph and find the biggest x value. If it said min, it'd be the smallest. Okay? So the biggest x value used is 7. That's it. 7. Right? That's the biggest x value on this graph. 7. Good? Okay. Let's do tomorrow's FRQ. It's easier than the next day. Okay, this one's pretty simple. It looks longer and more involved. It's actually pretty quick and easy. Now remember, each day you only have 6 multiple choice. Each day, 6 multiple choice and an FRQ. And this FRQ has a lot more going on in it. So if you're fading on me, please make sure you wake back up by the time we get to that, because I'm going to be really strict about it. All right? And I'll tell you what I mean when we get to it. All right, take a look at what we have here. Tomorrow's FRQ, 2 different functions, f of x, g of x. One is a graph, one is a table of values. Okay, and it tells us h of x is this, which equals that. So these two are the same thing, just 2 different ways of saying the same thing, by the way. Okay, we usually just use this one. This is the one we like better, but you can use either one. And it wants us to find h of 2. Okay, so h of 2 means I'm going to plug a 2 in right here. Anywhere I see an x, by the way. And when you see this notation, either one, it's composition of functions, where you're plugging one thing into another, and we always work right to left. So we start here, f of 2. This is x, right? So on the f function, go find where 2 is and tell me what you get. So on the f graph, when x is 2, y is 3. So we get g of 3. Now, it's still x. Go to the g function, find where x is 3. There she is. Y is 1.5. So 1.5 is your final answer. Okay? Why does it say or indicate that it is not defined? What if we got g of 4 right here? No, let's make it harder. G of 12. If I did f of 2 and I got 12, and then I got g of 12, well, I don't have a 12. If it's not here, then we can say it's not defined. Same with the graph. If this had original thing, it said f of, let's keep 12 again, f of 12, on this graph, there is no 12. This is not an arrow. It doesn't keep going. It stops there. It stops here. So if it asked right at the beginning f of 12, you'd say not defined. We don't have that information. It's not part of the graph. Okay? That's what it means when it says not defined. Okay, we know that this symbol means inverse. So normally, this means x. We see that symbol, it's y. You flip them. So, on the f function, go to where y is 6 and give me the x value. So on this f function, go up to y is 6, look left, look right till you find a point. There she is. So that point is negative 4, 6. So when y is 6, x is negative 4. There's no work to show, just being able to read the graph. And make sure you go to the right one, right? Not g when it says that. Okay, so look at g of x, and is it linear, quadratic, exponential, or log? Well, you can probably eliminate linear and quadratic on this test because that was unit 1. We're doing exponential and log. But just to remind you, looking at a table of values, we want to see what's happening with the inputs and the outputs. What I'm seeing with the inputs is that I'm adding 2 every time. So my inputs are changing at consecutive equal length intervals, and we'll talk about that wording again in a second. What's happening with the y values? Well, if I was subtracting 6 or adding 6 the whole way, that would be linear, right? You're adding or subtracting the same number. That's not happening. It would be quadratic if you were adding all different numbers and then the second differences were the same. Remember when you do the little arrows and you do a second level of adding and subtracting? On the actual AP test, you'll have to do all the tests because you won't be able to narrow it down to exponential or log. So we'll go over all these again many times. But what I do see is that if I go backwards, if I go this way, dividing, I get 1/2 or 0.5, doesn't matter which one. So that means I'm multiplying by 1/2 the whole way. Okay? So this is exponential. What would it look like if it were a log? This would be flipped. They're inverses of each other. So if the multiplying is happening to the x's, that makes it log. If the multiplying is happening to the y's, it's exponential. So it's pretty easy. Okay? This part, we need to know how to make this sentence, okay? So we have to say something about the x's and the y's. Usually using inputs and outputs is easier. So we want to, like, for example, I start usually the same way. Input, what did I say last period? Input values over consecutive, and spelling doesn't matter, consecutive equal length intervals. How did I say it last time? Can I change it? Over consecutive equal length input intervals. I like that better. Over consecutive equal length input values. Output values are proportional. If you looked at my key, it was slightly different. Whenever we're talking about multiplying on the x's or y's, so you would say the same thing for logs, just switch the words input and output. Proportional is the perfect word, okay? So log would just be the same exact thing, either one of these with the inputs and outputs flipped. So you want to say that the inputs are spaced evenly. And the easiest way to say that is consecutive in equal length input values or input intervals. There's a couple different ways. Okay, so I want to see some kind of proper wording here. One of these is fine. Talk about both of them. Spelling doesn't matter. Okay. Sorry about that. I'm actually not feeling great. I have like a sore throat. I'm trying to get through this day. Big, busy day for me. All right. Based on your model to determine the end behavior as g of x decreases without bound. Use limit. It's only asking for one, not both. Okay. So we're going to start by saying the limit of g of x. Right? That's what it said. Use limit notation. As x approaches what? In this problem it says decreases. It could say increases. So x is approaching, so decreasing would be negative infinity, right? So look at g of x. As the x's get smaller, what are the y values doing? Getting bigger. Clearly just freely getting bigger. You can't see it like the brakes getting put on, right? It's clearly getting bigger. There's not like, we've seen it was like 3, 3.1, 3.01, whatever, where you can tell there's an asymptote there. So as x goes to the left, y goes up. And it's all it asks for is that one. So that's all you're going to put there. Okay? So read the question, answer it. We'll be able to tell if people paid attention during this question and watch the video. All right. So that's tomorrow's. You know exactly what to expect. Good? This is the one I really need you paying attention to because I wouldn't be doing you guys any kind of favors if I just keep being too nice and accepting, oh, I know what she meant. I know she gets it. I know Zoe. I know she's just having a bad day. She knows how to answer this question. I can't because the AP graders don't know who you are, okay? And they're not going to give you the benefit of the doubt, typically. So I'm training you guys for that. So here we have an exponential function, right? Here it is. A times b to the x plus c. They're giving us the format of this equation, right? Right off the bat, what is the value of c? So we should know by now, please know this, that when you have a number all the way to the right, whether it's exponential, log, quadratic, that is the number that makes your graph go up and down. So looking at the graph, what do you think that c equals? It's -1. In this graph, without a c value, it would have been just a 0, right? That's the parent functions. So we don't put 0 there, right? Right. Now, it says to give a reason. So this will get you a point. You're going to get 2 more points for giving a proper explanation. Okay? You don't have to write both of these, but I want to see that you understand where we get this -1 from. So you can say C is a vertical shift from 0 to -1. That's perfectly fine. That's telling me you knew it was at 0, but that C value moved your graph down 1. Okay? Another thing, you don't have to write both, -1 represents the horizontal asymptote from 0 to -1. One of those is good, but I want you to make some connection between the movement from 0 to -1. Spelling doesn't matter, but make sure I can read it. Okay, so that's your reasoning. Now, use the points on the graph to find the values of A and B, show work, and then our final answer is going to be to write this equation. To write that equation, we need, guys, you should be really paying attention to this, A, B, and C. In our final answer, g of x is going to equal this, and we need a number for A, B, and C. Okay? We have C. We got that, right? We just found it. It's -1. And it gave us a hint here. Use the graph to find the values for A and B. Use points on the graph. If you, and I'll come back to this idea in a second, this is one of those you can't use the calculator for. And I'll explain that better. But so let me just tell you, when it says to use the points, you need to pick some points. They gave you 3, we need 2 of them. We're always going to be using the one that has a 0 in it. You definitely want that guy. Okay? That's an X and a Y. And really, after that, you can pick either one. So let's just all use the same one. You're going to use 2 points. Now, you might remember that and this is a calculator active, so you're allowed to use your calculator, but guys, I once upon a time told you that if you have ordered pairs, you can hit stat, enter, right? And you can go in here and put in your X's and your Y's. And all you need is at least 2 ordered pairs. And then you could go to stat, cal, exponential. Why am I saying that's not going to work this time? Because it's not me making you do extra work. Because other times we've had this type of problem, I said just put it in your calculator. There's no reason to do extra work. Why is it not going to work this time? Anybody know? It won't work. It's not me being mean. Because of the C value. If you think about your menu here, whenever you press any of these, any of them, and 0 is your exponential, there's no transformations. It's just the parent function. They're telling us that there's a C value, so that's why this will not work for you, okay? So we have to do it by hand. It's not bad. Let's just do it real quick. So I'm going to use this equation and plug in X, Y, and C, okay? So Y equals, I don't know A, I don't know B. I've got an X value, and I've got a C value. You guys writing this down? Because this is going to be a lot of points right here. And solve it. Well, how do you solve an equation that has 2 variables in it? Well, remember what b to the 0 is? It's going to be a 1, right? So first, but before I get to that, I would add 1 to both sides, right? I would have 2 equals a, b to the 0 is just 1. So a is 2. That's why you always want to start with a point that has a 0 in it. That way, one of your variables will go away. And it'll usually be you'll be given this point. Okay? So now, I'm going to use my second point and plug in X, Y, A, and C and solve for B. So, Y equals, I do know A now, I still don't know B. X is -1, C is -1. So I just plug X, Y, A, and C in. Add 1. Hit both sides. Divide by 2. And guys, I did it one way on my key. You could do it that way. I'll show another way here. Is anytime you have a negative exponent, that you can make it positive, because we do need it to be a positive 1, by having it cross the fraction bar. So you could have 2 equals, put the b in the bottom, right? That would make it a positive 1, nothing left on top, so we'll just call it a 1. And then just multiply both sides. Remember, if you multiply a fraction by its denominator, do it to both sides, the denominator cancels. If you multiply a fraction by its denominator, it will cancel. And b is 1/2. Now you write your final answer. A times b to the power of x minus 1. Plugged in A, B, C. This is what you would need to show me for full credit. If that C weren't there, you would be able to just use stat calc. All right, now we're going to find the inverse. Switch x and y, solve for y. This is the last bit of work. X equals 2 times 1/2 to the y minus 1, right? So I just switched x and y. This was the final answer of this one, and I'm finding the inverse. Switch x and y, and then solve for y. So this is exponential, right? The inverse is a log. So I'm going from exponential to log. So this is going to have to become a log. And we learned how to do that. Log, find the base, all that stuff. It's the opposite of the loop-de-loop. But there's some rules about it. Before you can write an exponential as a log, there's cleanup. You can only have the base and its power on one side. So if there's anything else on that side of the equation, it has to go. I need to add the 1, divide by 2. Do I need to see those steps? No. I need to see add 1, divide the whole side by 2. That's enough for me, okay? But you have to do that before you can solve this. It's the same idea. Let me show you again real quick. To go from log to exponential form, you had to have log base argument by itself, okay? So to go from log to exponential form, that was the cleanup that was involved. To go from exponential to log form, you had to get the base and the exponent by itself. Now you can write this as a log. Start by writing the word log. The base of your exponential is the base of your log. Remember that power? He's a loner. He likes to be by himself. He goes to the other side. And whatever's on the other side of the equation is your argument. We now have our inverse. Notice it says show all work. That's the work. Use correct notation. Here's correct notation. This is what I'm looking for. This is where I'm getting more strict with you guys. And it's very fair of me because I'm giving you a review, I'm doing it with you and showing you exactly what to do. You just have to do the same thing. Last question. Domain and range of the inverse. Guys, you have a graphing calculator. We've hardly used it for this question, but you could have if you needed to at any point. You could put this in your graphing calculator and look at the graph and table of values, but I have an easier way than that if you ask my opinion. If I know the domain and the range of this, all I have to do is flip it. And remember, I love to do domain and range from a picture. It's so much easier in my opinion. So if I just quickly find the domain and range of this, I just flip it for the inverse. This is an exponential function. The domain of an exponential function is all real numbers. Look at the picture. There's nothing stopping it from going left and right. There's nothing blocking it left and right. But up and down, there is, right? Least to greatest would be -1 to infinity, right? -1 to infinity. Just literally flip it for the inverse. Domain would be from -1 to infinity. Range would be -infinity to infinity. So much easier than spending time typing that in the calculator in parentheses and, 1/2 or point, what do I do? Okay? That's it. That is it. Is there anything anybody needs me to go over? Anything in 1 through 6 even? Yeah? This here? So whenever this is like, we call it K sometimes, when it's not sectioned off with an X, like, in parentheses or hanging out the X's left or right, opposite. The number all the way to the right is your up or down. So knowing what we know about exponential functions, you can see that there's an asymptote here at -1. So the parent function solely would have been at 0, right, for all a times b of the x, whether it's decreasing, increasing, right? It would look like that or like that, where you have that asymptote y equals 0. That's because there's no number out to the right, right? So it's 0. The minute we move that graph up or down, we have a c value. Okay, so we went from 0 to -1. That's how we know. C is -1. How's it? Tomorrow's no calculator. Anything else, Lily?